5.2 is titled A Catalog of Forces. There's a very interesting point being made here in the catalog, and I will get to it. It's when he talks about the normal force and the frictional force. Let's just go through the catalog, though, in the order he has it. He talks about the force of gravity. In the case of the eraser, I had gravity, and I call it F2. Very often gravity, just to remind you that it's gravity, will be F sub capital G. So the downward pull on this eraser is denoted like that. Another common kind of force in physics laboratories and in mechanical systems in general is springs. So here I'm drawing a spring, and even though the spring touches the thing here, we usually kind of draw the forces as all emanating from the center of the object because we model these objects as particles. So if you want to add the force of this spring, which is in the upward direction to this picture, you'd probably add it like that. And there you would label it F spring. So now we have two forces acting on this eraser. We could also have a rope pulling on this eraser. So here I've drawn a rope. Maybe it goes over a pulley and is attached to some weight somewhere. So there's a rope pulling on the eraser. The way that Knight would denote that is, once again, he'd put all the tails of these together, and he would add a new vector that points in the direction that the rope is pulling. And he could call this F sub T for what we call tension, but actually on this one he breaks the pattern a little bit, and he calls that T for the tension. Now I get to the really interesting one. Remember, I had my hand over here, and my hand was pushing on the backside of the eraser. This here represents a surface. A surface has a perpendicular. Okay, so I'm going to try to draw a piece that's perpendicular to this surface. And once again, we put its tail in the center of the object. So there's a piece of my hand's force on this eraser that is perpendicular to the surface. And we can call that, normal is a synonym for perpendicular. We can call that F sub n. Now, if my hand's really slippery, the only direction I can push on the eraser is perpendicular to the surface. But if my hand is kind of sticky, then I actually can push somewhat parallel to the surface of the eraser. So in principle, there's a component of this force of my hand on the eraser that is not just perpendicular to the surface. And this force that's parallel, let's suppose I was pushing this direction on the surface as I was also pushing this direction. If my hand's not slipping, we call that the force of static friction. I've written it all out there as F sub static friction, so that Knight doesn't have to write all that out. He makes a lowercase f and he subscripts it s. Now, so this vector that's parallel to the surface and represents the push of my hand in that direction is F sub s. Now, actually, if my hand's slipping but still pushing in that direction, he doesn't call it F sub s. He only calls it F sub s if my hand is sticking and pushing in that direction, so that my hand and the eraser are not moving relative to each other. If my hand and the eraser are moving relative to each other, then he calls it lowercase f sub k. And so this is known as static friction, and this is known as kinetic friction. There's three more forces in the catalog that Knight has here. One of them he calls the force of drag. That's like the typical case of drag would probably be air resistance. Another one he calls the force of thrust. Particles in the exhaust actually pushing back on the back of the rocket before they spread out into the atmosphere behind the rocket. And then the final one, and this is actually the subject of the entire second semester, is electric and magnetic forces. That's a pretty big catalog, actually. Even without electric and magnetic forces, which is the subject of the whole second semester, that's quite a catalog. That's enough to help us get a lot of entertaining and illustrative examples that will help us become familiar with forces.